Okay, thank you very much for coming to the uh, Cobalt Pre-NAB webinar. Let's get right into it. All right. I don't know if you noticed, but over the past year or so, Cobalt has renamed our product families. Um, so we're now using the name Wave for routers, ARIA for audio, UltraBlue for the multiviewer. The compression stuff is now under Pacific. It's all shades of blue. The converters are Sapphire. The 2110 stuff is Indigo. Well, we have frames in that's APF, HPF Max. Well, we have the existing blue box group for the little boxes. We're calling Royal the distribution amplifiers, and there is Cyan, the fiber stuff. So there is a lot of new stuff. This webinar is not about everything we have. It's just about what's new. And we can be very informal here. If you have a question, just unmute yourself and ask. You don't need to wait for the end. All right. So agenda for today, we start with the UltraBlue IP Multiviewer and what's new with that. Then we're going to take a look at the IPMX solution, which includes the Indigo and Sapphire product lines. We'll talk about the audio monitor, the ARIA Audio Monitor. That's not a new product, but Chris is going to give us an overview of the OpenGear frame solutions. We have new stuff on fiber, the Cyan fiber solution. So there's some new stuff that we'll talk about with fiber. And we'll give you a preview of the NAB 2025 boot, including the couches. Let's jump right into it, UltraBlue IP Multiviewer. So we talked about this last year. This is now ready to ship. It's a software-based multiviewer that can be scaled to an arbitrary number of inputs and outputs. That scaling is through putting more servers. So it's a PC server. And for inputs, we are supporting compressed video over IP, and we'll support UDP, RTP, in fact, RIST, RTMP, and others are coming. It supports baseband over SMPTE 2110 with NMOS support. So that requires a proper card. And what's new here is also SDI with capture cards. This is a full feature multiviewer. There is no detail missing. You can do arbitrary rotation of screens and pips. So very important. Sometimes you want a landscape or a portrait screen. We do that. You can arbitrarily position the pip and size it any way you like, and you see demos of that. Audio bars, UMDs, closed captioning, graphic overlays. We're big into graphic overlays. That looks pretty cool. User management. Obviously, we have clocks. We have alarms, which is new, and I'll talk about that. I have a slide on that. Tally, which is par for the course, and output audio routing, which means you can always select the pip and say, I want to listen to this one. So the product's available primarily as a software package to load in your own hardware. So you procure your own PC and you put the software in it. We'll take over the whole PC, right? They got to be a blank PC. But we can also provide in some cases a turnkey hardware solution. How do we sell this? This is per input stream. You can have as many heads and you can have as many pips as you want, but it's per input. So if you're putting together your own server, what you need is an NVIDIA GPU with Vulkan 1.3 support. We prefer the A4000 or better. For ST2110 baseband input, Mellanox Connect X cards with a RiverMax license. That's required. For the turnkey solution, it's a Dell server with 4 display ports and 48 inputs, 24 hyper-threaded cores. We do a calculation of essentially one stream per hyper-thread. So that is over here. We have an example. This is how you do a pip layout in the multiviewer. You can see I have 5 pips on the top. With this size, I have 2 big ones here, 4 relatively small ones here, another 5 over here, and different sizes, and I have an empty space here. And you can see there's a grid to help you position, and you get to decide how big that grid is, or how fine that grid is. Here's how you route. You have here all your inputs. You see little thumbnails of what's going on in the input. You see the resolution and the type of signal, type of audio. And it's as simple as you click on the pip and then you click on the input and that's it. That's actually pretty nice to do with a touch panel. You just touch, and then you have the pip there. I don't know if you see here, maybe too small, but there's a little loudspeaker here. That's the one that audio is coming through. And you can just click and select a different one if you want that. Here's this actual multiviewer in running. So let's see what I have here. The top bar is an ATSC feed channel, RF channel 27 from Champaign, Illinois. You see here that it happens to be 5 SD streams, and most of them have closed captioning. This one doesn't. And I kind of put a nice label here or what the program is. The bottom is another one. It's 5 programs, but these guys are HD. It doesn't matter HD. The size is what I say the size should be, and these are SD. But since these are HD, I made them bigger. This guy here is an RTMP feed with a bouncy box. This is an HVC camera. It's the view outside my window right now. Actually, this is not right now because this is a static image, but it was running at the time. These two are wrist streams from California. So I'm sitting here in Illinois, and those are off-air channels from California. They are being transmitted here through wrist. And I don't have a label, but these guys here is the same as some of those transcoded to 264 on a Cobalt transcoder. And we have some nice overlays there. There's a little clock here. It was 1:53 p.m. when I captured this, and I just made something nice here. So you remember us, Cobalt UltraBlue. New feature. So the multiviewer we talked about last year, but new feature is the SDI input and output. We're supporting the DAC DTA 2178 that has 8 SDI inputs, and you can put multiple of these. They are capable of operation up to 12 G SDI. You can bring in 4K, but 4K is internally scaled to 1080p, which is not a big deal because you're going to scale it down for the PIP anyway. Supports all of that, audio, video, and ancillary data inputs. So you want SDI inputs, you got SDI inputs in the multiviewer. It's got compressor, you got SDI, and you got 2110. Another new feature is monitoring in QC. What QC functions do we have? Video, loss of video, that's obvious. There's no video, you have an alarm, but also frozen and black image with a region of interest. So you can it can be the whole video or just a piece of it. Audio, loss of audio, if it's actually not coming, or silence detection, obviously with a configurable threshold. We are also monitoring and watching ancillary data, again with configurable thresholds, loss of closed captioning, and that's both US closed captioning and OP47, loss of SCSI markers, which is either SCSI 35 if it's compressed or 104 if it's baseband, and loss of each-chip. The monitoring is independent per PIP, and you can configure independently per PIP severity and priority of the alarms. The alarms show up as a red border. Now, let me talk about roadmap. This is stuff that's not available yet, but it's coming in the next few months. So if you have a DAC card, we'll support an SDI output. Right now, we're supporting HDMI or DisplayPort. If you have a Mellanox card, we'll support the 2110 output. And if you have neither of that, or if you want it, We'll support compressed output, so you can generate a RISC stream with a transport stream sent to some professional decoder, or WebRTC, you pull a browser and you can watch what's happening in the multiviewer. For monitoring QC, we're going to introduce the penalty box, which is actually quite useful. You have sometimes you have walls of multiviewers, but you're not going to be staring at every single pip there. You want to note the ones that have problems, right? So we put a red border right now, or yellow border if it's a yellow alarm. But penalty boxes, you dedicate an area of the multiviewer, and if anything shows up there, that's the one that's in alarm. We are adding additional protocols and codecs. SRT is not available yet, but will be RTSP for protocols, JPEG access for codecs, and full IPMX support, which is coming. We essentially have it, but I'll defer that when we get to the IPMX discussion. All right, let me stop right now and see if there's any questions on the multiviewer. You can unmute and ask or put it in chat. Or if not, I'll keep going. All right. Next, IPMX solutions. So little intro to IPMX. If you haven't heard of it, IPMX is just 2110 made easy for plug and play. So it's 2110 for Pro AV environments. As Pro AV today is fragmented on proprietary solutions, IPMX is I can't say standard because it comes from the Video Services Forum and the AMWA, but it's a open specification. So, and there's no limitations to deploy it in broadcast. What the main differences between IPMX and ST2110 are: IPMX requires NMOS for control. In ST2110 is technically optional, but in practice, everybody's using it anyway. So NMOS is there. The other thing is IPMX does not require PTP. You can do PTP, but it doesn't require, because that's one of the places where you trip in 2110. Everything has to be synchronized to PTP. In the IPMX, you don't care. So you don't have to set up a grandmaster. You can use much cheaper switches. All right. And then JPEG access is an option for lower bitrate operation. So JPEG access is supported in plain vanilla 2110, which is 2110-22 with TR08 extensions, because 22 is insufficient. You have to talk about TR08, but it's part of JPEG access, and it's actually a requirement, I believe. All right. So what's new? The firmware on all Cobalt ST2110 devices, both Indigo and Sapphire lines, is being updated to support IPMX. So the new features include asynchronous operation, no PTP, audio SRC. So why do you have PTP in 2110? Because you can mix any audio with any video, any ancillary data. But if the audio is asynchronous to the video, have this video source and that video source, you have to do sample rate conversion, SRC sample rate conversion, to mix this video with that audio that didn't come with it. We'll support JPEG access using VSF TR08, and that's additional license because we got to pay royalties to the JPEG access people. Support for RGB 444 and conversion to YCRCB 420. And there's some protocol extensions that will support. This is under the hood. We don't need to talk about that here, but just know that it's going to be there for compliance. Well, we have a few new boxes that are going to help us go into the IPMX. And if you look at the picture, they look exactly the same, right? Because we use the exact same method, exact same box, but we have two new boards there. The existing box, the SAPPHIRE BBG-2110 4H, is got four HDMI outputs. So it's an output box to drive, primarily to drive monitors. There's two new boxes joining that family, one with four HDMI inputs. So it's an input box, you go in HDMI. and one that's mixed. There's two HDMI inputs and two HDMI outputs. We could have designed something with bidirectional HDMI, but that would become too expensive, so not worth it. So we designed fixed function boxes. Right. All right. So here is a nice little picture of all the Cobalt IPMX capable devices. So everything that touches 2110 for us is going to have IPMX support. So that includes the Indigo bi-die gateway, the two little BBGs, single and dual channel. These three new boxes I talked about. One is existing, the other two are new. The encoder has got a 2110 interface. We talked about it last year. Now this is going to be IPMX compliant. And the Indigo Plus 9904, 9905. And I'm not going to go through the specs. You can have a copy of this slide deck in PDF after the meeting. And then you can read this stuff. But it's just to know what's going on there. Let me stop here and see if there are any questions on IPMX before I dive into the ARIA Audio Monitor. Okay, I'll keep going. I can talk fast. That's fine. All right. ARIA Audio Monitor. We showed that between closed door last year at NAB, but that's now going to be shipping. It ships after NAB. So let's talk about the features. There's two versions coming out now. One with the dash H. H means horizontal. The buttons are horizontal, and the dash V, where the buttons are V-shaped, and the bars are going to be turned around 90 degrees. So one ARIA rack mounted is 4 inches deep and it weighs 4 pounds. So it's small and light. We have redundant power supplies plus PoE++. So you can just connect to the Ethernet cable to it and power it that way. We have a full motion video thumbnail, SDI analog outputs, and I'll show you the back of it as well. That's the only old slide I have. I showed that at IBC last year. I'm going to show it again. So one key point here is that this support goes up to 12G, supports 4K. So we have two SDI in and plus two SFPs for fiber. We'll support MADI, Dante, AES, analog balance, and 2110 up to 12G again. A couple of those are futures, but I'll give you the roadmap in a bit. Let me give you a flavor of the front panel. So that's the front panel you saw in the previous picture, just expanded. You have your normal audio monitor stuff, plus a little SDI video thumbnail. When you touch it, the displays touch, it goes big. Now you're seeing. You probably saw that movie, it's The Martian. If you have more channels, this is a MADI view with 64 channels. And this is a historical level view. So good stuff to have. Another historical is this. It's a 30-second historical view. So you see here on the purple side, we had a loss of audio in the past. There's an on-screen keyboard. You can configure it to a web interface too if you don't like touch displays. But if you do, there's an on-screen keyboard. Here's an admin panel showing the fan speed. And this is just for demos, a WAV file select. You can load WAV files in the thing and then play them. Doubt that you're going to actually use that, but it's there. Here's the back of the thing. The only old slide I have is the back of the thing. You have the analog inputs, SFPs for ST2110, and would be 1025, and 2 because you want to support -7. Control Ethernet with PoE++ support. Redundant power inputs if you don't want to go PoE, or if you want to go PoE, then you have 3 powers. The same SFP support SDI over fiber is a configuration, is actually firmware option. Your SDI and MADI inputs supporting up to 12G. Your SDI MADI output. So once we have 2110, you can be able to come in 2110 and have an output here on SDI. So we'll save you a gateway. AES input, balanced audio balanced analog audio outputs if you don't want to use the built-in speakers, and GPI for future use. I haven't thought about how to use that, but it's there. We'll find out a feature. Here's the roadmap for the audio monitor. Dolby support. It will start with AC3, AC3, AC4, and Dolby E, and other formats will come over time. Support for Dante is not going to be there day one, but it's coming using the SFP ports for input. Support for SMPTE 2110 with audio and video pass-through to SDI, saving you a gateway with obviously NMOS and IPMX support. The other big thing that's going to come back is support for asynchronous mix of inputs. Right now, you only watch one input, but you'll be able to mix and match audio channels from different inputs, and they don't need to be gen locked. So that's why we say asynchronous. Let me stop here and again ask if there are any questions on the audio monitor. Okay. No questions. And oops, too much. Now I'm going to pass it over to Chris, who's going to talk about Cobalt OpenGear frame solutions. Take it away, Chris.
Okay, thank you, Cyril. Thanks again, guys, for being here. If we can go to the next slide. So this is what we're showing here in this table. We wanted to put together a comparison so that users could essentially decipher exactly what is it that we offer within Cobalt as far as solutions for housing our cards. But it doesn't have to be our cards. It can also be third-party OpenGear cards that are out there in the market. Traditionally, most people understood that we had the HPF 9000, which is the Cobalt original design and manufacture. The OGX, this is the one that's shared within the OpenGear group of anybody that supports OpenGear. But as of this year, now we have two new models. The ones that you see here, HPF 9500N, and there's a couple other variations, and I'll explain a little bit more what that is. And then we also have the HPF Max. This is what we call the super high power frame, which has the maximum allowable input and output as far as power. And then to the far right, we have one that we've been kind of discussing this for some time now, but I just wanted to put it in the context of what is it that we offer within the OpenGear. So this, the 1300, this is for those customers that need and want to have a very portable standalone solution for, let's say you want to, have an encoder or a card that has multiple channels, but in a portable package. So on the far left, starting with the 9000, if you can see there, essentially as far as how they physically, look and how they physically fit in a rack, that's basically the same as the other two RU frames that we have here on the list. There's some slight differences with the weights, as you can see at the very bottom, depending on what frame it is. Ours, for the most part, tend to be at a reasonable weight. So let's just say you're putting together a fly pack, a truck, that might be a consideration for you guys or for the customers, really. The very first one, the HPF 9000, that has been discontinued. Now that has been basically replaced by the HPF 9500. And one big change that we essentially designed into this new 9500 is the ability to have distributed Ethernet within the midplane of the switch that we have on the or the backplane of the frame itself. So in the past, when customers wanted to have that distributed Ethernet to be able to have a little bit more dynamic networking within the frame, if you had cards from other manufacturers, maybe from us, that was always an issue, and you always had to go back to the OGX to give you that flexibility. Well, now, if you fast forward, we can offer that with our HPF 9500. And one of the benefits is that, well, it's a little bit lighter. So if you want to put it in the truck, you can get that in the truck, and it'll be much lighter. It's a little, sturdier than the OG3 OGX. And then also one consideration is that, let's just say in the past, uh, we've actually played. I mean, we can discuss, in the recommendation that we made in the past is that if you wanted to have the maximum allowed, let's just say within a 6RU space, available space, you always had to kind of have a 1RU spacing between frames at the top and at the bottom, just to be able to have enough cooling, especially when you have a lot of power coming out of the cards. Well, in some of the new applications that we've actually installed our frames, we had to take that consideration, but the new frames that we have, that kind of addresses that cooling factor. So now you can easily accommodate 3 frames in a 6RU space and be able to give you the maximum amount of power output. So basically giving you more density, about 50% more capacity than if you had with the other previous frames. So if we look at here at the power input and output, there are some differences, right? And now the HPF Max, this will give you the most allowable power input and output. So if you were considering the OGX in the past for more dynamic, for more power applications, well, now you can look at the HPF Max because this is actually giving you a little bit more, and it has a lot of flexibility. So for example, one of those flexibilities is that if you're within the open gear world, traditionally you would have to use dashboard to access the cards in the frame. If you use one of our frames, you also have dashboard, but we also offer what we call this web UI, where you directly talk to the frame and all the cards in the frame through a web UI, and that'll basically emulate a very similar look to dashboard, but it's a little bit more dynamic. It's quicker. So if you have frames that are at a very distant location, for example, you're in California, but you want to talk to frames in Brazil, you can easily talk to them with the web UI because it's a little bit more dynamic and there's less negotiating going on it within the frame and the network card through dashboard. So that's an option if you use our frames. The other thing is that besides that, the HPF Max, for example, we offer what we call sophisticated cooling. So if you have maybe not an entire populated frame inside, you don't have all the cards inside of the frame, you can tune down the fan speed so that it runs very quiet or almost as if it was off. Let's just say you have 2-3 cards in the frame, and maybe the application is a studio where it needs to be a little bit quieter. This frame can accommodate that. It has what we call sophisticated cooling or sophisticated fan speed, where you can easily tune down the speed of the fans and it'll give you that environment. It's very similar with the 1300, but I think the HPF Max, being a bigger frame, it kind of really gives you that flexibility because now you can have more than one card in the frame. So again, this is a new line of frames that we have. Again, the HPF 9000 has been discontinued. You may not see that anymore. So whenever somebody is asking you for an open gear frame, please look at the 9500 and the HPF Max. We still have the OGX FR. There's different options for that as well. But from our position as Cobalt, we strongly urge customers and partners to look at our new frames because we offer the same flexibility as the OGX and the previous ones. And then also having that gigabit Ethernet on the mid plane to be able to share the data between different cards. That's also an added bonus and flexibility, plus being able to access the frame and the cards through the web UI. So again, this is the new lineup. Whenever somebody's asking for a quote, just be mindful of this. And as Cyril said, we're going to pass this along to you guys so that you guys can digest this a little more and be able to look at what the differences are for all these frames. Next slide. And so, for example, if you're, you're being asked to put together a portable standalone application where you have, let's just say, multiple encodes within a small footprint. One consideration is, as I'm showing here in this slide, is the BBG 1300 plus our 4-channel encoding platform, the one that Sarah just mentioned. You could be also running some encodes from IPMX. You can also have 2110 to ABC or HEVC. And all that can be easily and nicely constrained within a small footprint or a small package that can also talk to the same network where you have other 2RU frames within your workflow. So this is a nice consideration if you're having to add, some maybe a couple of channels, 4 channels more into an existing infrastructure where maybe you have, let's just say, a bunch of open gear 2RU frames, but maybe all you need to do is just add a couple more channels of the same process, but in a smaller footprint, because maybe your real estate in a truck, in a facility, has basically run out, and now you basically all you have is a 1RU space where you can easily mount something else. Well, this will be a great option for you. And so again, this is the 1300 FR that has redundant power. It has all the access to dashboard, the web UI. You can also do SNMP alarming, monitoring, and it's very easy to deploy. Next. And then, as I said, if you're going to be, if you want the most density, if you want the flexibility, and you want to be able to talk to not just our cards but other cards as well, this would be the 9500 would be the next step up. This certainly will give you that same flexibility, but just be mindful that the power that you have within this, although it's sufficient enough for most applications, anything beyond the 360 watts that we can actually manage within this frame as operational power could be quickly taken up by a number of cars. But for this scenario, as I'm showing here, we have 10, 99, 15 DA cards. These are basic distribution amplifiers that also happen to have fiber SFP ports. You can easily accommodate, for example, 80 fiber to SDI conversions with dual SFP modules, so that you can easily visualize what can be done with a frame of this capacity and within those type of cards like the ones that we offer here. Next slide. Our next. And then for consideration, if you look at the HPF Max, as I said, this is the one that allows the most maximum power output. So if you look at this, now you have essentially a product that gives you the most flexibility, right? So now you can easily mix and match a lot of different power consuming cards. For example, at the very top there, we have 4 Indigo bidirectional cards that do take up or consume quite a bit of power. So if you wanted to use this card, you can do 16 conversions from SDI to 2110 back and forth. And then at the bottom, we have 4 encoders, the Pacific encoders that have 4 channels that can also do 2110 or IPMX conversions or encodes to HEVC or ABC. And that'll give you an idea of what type of combinations, the configurations you can do within the frame. And again, in our recommendation, if you do plan to have a customer consider a very high power hungry application, in our opinion, the HPF Max is going to fit the bill much better than even the OGX in most cases. And again, you have the added flexibility of being able to access the frame not only through dashboard, but also to be able to access it using the web UI and also have all the SNMP monitoring and traps and all that. So again, this is just to give you guys an idea of how these frames can be easily deployed and what type of considerations you should be thinking of when looking at these frames. Next. And then does anybody have any questions before I go to the next? Okay, next slide. So now we're going to look at the Cyan and Blue Box fiber solutions that we have. So we, as of last year, we started this move towards offering more 12G supporting or 4K supporting devices. Some of those devices now, what we have here are these fiber products that are basically, as you see here, in the small little blue box, small portable form factor. But we also just added, as of this year, the Cyan open ear based fiber solutions that support 12G. So what we're looking at here is essentially a table that breaks down exactly the inputs and outputs for those little blue box devices, but also for the open ear cards. For the blue box, we have from a single one input, one output configuration, also dual two in, two out. And then for the open gear cards, we decided that it just made more sense to offer the most density per car. So in that consideration or in that design, we offer the two-channel versions, which is two channels input or output. So it can be fiber to SDI or SDI to fiber. That's what we offer in that to give you the most density within a frame. But we also have a transceiver, so that's just to give you that flexibility of being able to send and also receive within the same card. Because again, these cards, by the way, these channels, the inputs and outputs, if you have the dual, are essentially discrete channels. So those are independent from one another. So you can have easily traffic going to and from or bidirectional in the case of the transceiver. And all these cards can be easily monitored, like I said, through dashboard or through the web UI within the frame. And in the case of the Throwdown BBG Blue Box, these have their dedicated UI, which we call BBG config. If you were not aware of that, that exists. That can also monitor other little blue box devices out there that we also sell. Next slide. So this is just to give you a little more perspective. Again, this is the SDI to fiber car, a little box, sorry. This one supports data rates from 5 megabits to 12 gigabits, again, in multiple formats from SD all the way to 12G. We offer different connector types, ST, LC, and FC. And these are, in our view, these are very, very good quality fiber transport devices. So when we design a product, we never cut corners. So we typically design if we're designing a car, we share that same design with the smaller footprint devices. Obviously, there might be some limitations with the small little boxes because of the form factor. But in general, the design, it's basically shared across different, whether it's a small little throwdown or a fiber card. So again, the same quality that we offer within the card, we also offer with this. Next. And then again, this is the dual. So again, as I said, these two channels that we offer, the SDI to optical, these are independent. So whatever we offer on the first single, we offer it on the second. Again, same options. Next. And then that would be the single optical to electrical receiver. Next. And then again, that would be the opposite end for the optical, the two optical to SDI receiver. Next. And then for the cards, as I mentioned, it's essentially the same. One thing that I should mention is that in the past, or as many of you guys know, every time you order a product from us, you have to specify the backplane. In this case, if you look at the card itself, when you get to know this card, or when you see it for the first time, this card on the main PCB board, we actually have silkscreen the backplane look so that you can see exactly what you're getting. Now, this same model will be the same for the 3G version and also the 12G. And what we've done this time, instead of actually adding a backplane, it'll be part of the card itself, because the design of the fiber is actually built onto the card itself, as opposed to what we normally offer with other fiber solutions where it's an external SFP and you have to define exactly what that is. So in this case, it'll be part of the same design, and the backplane essentially is just going to be just a plate or an adapter that just fits right into it, because there's not going to be like, 4 or 5 other variants of this card. It's going to be a basic design. And again, with the basic design, that means it's a much better price point, so that if you're offering it to a customer that has a certain budget, this is going to allow the customer to really quickly jump on board with using Cobalt cards. Next. And again, this would be the opposite, as I said, to be able to attain the density. We basically just stopped at the 2 input to output. And then also one other consideration point is that this will only come with the LC connector, so there is no ST or SC. So if you want those ST or SC connectors, the recommendation would be to use the small little blue box that I just mentioned in the previous slides. Next. And then this is the transceiver option of these 2 cards. So again, as I said, you have the option to have a fiber input or an SDI input, and then you can just switch back and forth depending on what the application is. And these formats that are supported with these 3 cards is from SD all the way to 12G. And as I said, they have a ton of flexibility. Next. And then to quickly just summarize exactly where you would certainly use these. For example, if you have access to an open gear frame, the natural recommendation is to use the open gear versions of these products because you'll get the most density. You have a centralized point of managing these cards. You can monitor, like I said, through dashboard or the web UI. And in most cases, if you're doing a large event, if there's a large transport of fiber over long distances or from big locations, then the fiber cards, the open ear cards, will be the better option for you guys. But if you're in the field or you have a small little fly pack or you need to add on additional channels to an existing workflow, perhaps you want to consider the small little blue boxes, right? And as I said before, the design and the quality is essentially the same between the open gear version and the small little blue box. So there is no difference. The only difference is the form factor, right? So you're getting the same quality and in some cases the same density if you go with the 2 channels, but just slightly different in terms of the way you monitor them and the way you configure them, right? But the nice thing is that you can have, or the customer can have, a few of these, on hand. And if somebody says, "Hey, I need to add a few more of these, but I do not have space or a way to mount an open gear frame," well, you can easily put these somewhere and be able to power them, and they do not require too much power to be power from an external source. So this is just to give you guys an idea of what is possible and what we have. As Cyril said in the beginning, these are new devices. We have a lot of other older stuff that sort of resembles this, but more on the SD and 3G domain. And that's it.
Okay. Any questions for Chris on the fiber stuff? Thank you, Chris. So we get to the last part of our presentation, the NAB boot demos. We are in South Lower 5123, easy to remember, 123, 5123. So if you're coming to Vegas, please come see us. We have a couch. I have several couches. So as you can see here, we'll have 4 demo areas, one in the back, and then 2 over here, 1 over here, and the other side of this is a traditional wall of cards. So come and see us. And as Susanna said, there's a cocktail Monday at the end of the show. Here's the core of the boot. It looks somewhat similar to last year, but it's not quite the same. We have in my color codes here, green is SDI, red is 2110 or IPMX, and blue is compressed. So as of last year, same as last year, we're going to get a stream from Champaign, Illinois. It's camera in my office. You see what I see from the window. Will come to decoder. It will be available to as an SDI signal, also available as a RISC clean stream for the multiviewer. We're going to have a multiviewer in the core. We'll have SDI to 2110 converters. We'll be pretty much running an IPMX network here. The multiviewer will then be showing compressed streams from here and from here. We'll have an encoder converting 2110 to compressed and directly 2110 stream. So we'll combine all of that in the multiviewer. and we'll be running that. So this is the Multiviewer demo and is also signal generation for the rest of the boot. We'll have a dual channel reference generator here for another demo. Next slide is the IPMX demo pod. This is just to show an IPMX end-to-end where you have a laptop with HDMI into one of the new boxes, then becomes IPMX, and then gets into one of the SAPPHIRE converters. And this is a really simple demo. You wiggle the mouse over here, you see wiggle at the same time over here, because the latency through this, even using JPEG XS compression, is negligible. So very good for very low latency production. So it's a simple but effective demo. We'll have a REMI demo pod using our ultra low latency encoder and our new Pacific ultra low latency decoder. We'll have two signals from the reference generator. I'm showing them the same here, but at NAB, they're actually going to be different. You'll see the difference. I use different test pattern on them and different color box, but you will be able to see the input, the output. So negligible latency over here, and then we'll switch between one and the other over here using the router and the control panel. So that's very, very powerful demo. And the final demo is the ARIA demo pod. We'll have the Dante card, which we introduced last year, so it's not new, but we'll have it generating, picking up a Dante stream, generating an SDI signal, and we'll have a number of SDI signals coming to the audio monitor. So you'll be able to listen to them. You'll see the video displayed on a monitor right next to it. You're going to be able to select stuff here, but essentially you will be able to select stuff here too, and just listen to the audio. So we'll see the kind of the full feature audio monitor in operation. We're not going to have the ladybug, it'll be different video, but you'll see some nice looking video there. And that's it. That's the thank you slide. Again, I'm going to open it for any questions you may have. If not, we can type in on the chat. You can unmute and say and talk to us. And you can also meet us one-on-one at NAB if you're coming to Vegas. I'll be happy to see you there. I'll be there. Chris will be there. Susanna will be there. So we're happy to see you. Floor is open if you have questions. I can answer anything except how much something costs. Then it's Chris and Susanna. Okay. Thank you, guys. And I'll see you in Vegas.
Thank you, everyone. Thanks for joining us. See you in Vegas.